All right. Excellent. All right. I think we good to go. Well, thank you, first of all, Ashley, for having me. Thanks for including me in the event. I'm very excited. I'm sad that I couldn't be there. That would have been more fun. I'm based in the UK at the moment, but that's quite all right. And thanks everyone for joining. I'll get rolling. As Ashley mentioned, I'm ever so happy to be interrupted along the way. If you've got questions along the way and you want to put them in the chat, please feel free. I've got my chat window open here, so I'll try and keep an eye on that. And hopefully I won't get wrapped up in my own slides so much that I don't spot them. But please feel free to call out any questions, and anything we can't mop up along the way, we can get into some conversation at the end as well. That's all good. I feel like maybe I should start by doing a small introduction, just so that you know who I am and who's talking in your general direction. My name's Phil Hawksworth. I work in the developer experience team at Netlify, and I'll talk a little bit about who Netlify are along the way. I'm based in the UK. I'm just outside London, so that's why it's a bit moody in here. It's a little bit dark now. It's a bit in the evening, but as I say, I'm very excited to join you for this. I used to say at this stage of any presentation, if you've got questions afterwards, throw them at me on Twitter. That's great. And I would just kind of promote my Twitter handle there, which is @PhilHawksworth. Be honest, I'm not really active on Twitter these days for reasons. Things have changed a little bit there, so I'm actually elsewhere a bit now. You're more likely to find me on Mastodon. I'm still @PhilHawksworth at IndieWeb Social. So I'm very happy to take questions there later on. If something occurs to you a little bit later, you think, oh, if only I'd asked, please seek me out and ask me on there. To be very honest, though, what I should probably be doing these days is I should just be putting my website on there, my domain. I've had this domain for 25 years or so, and it's a website that I own, and it's a domain that I control, and I publish things on there. It's also an example of something which is a recurring theme throughout this talk. It's not the main subject of the talk, but it is definitely a theme, which is naming is hard. Choosing a domain name based on what you think is a cool spelling around your surname. My surname is Hawksworth, and this domain is meant to be Hawksworks. It's a stupid domain. It's not cool. It's not clever. People don't know how to pronounce it. People don't know how to spell it. And it's the first example of naming being hard. And I say that because, fair warning, this slide is coming your way shortly, because naming is indeed hard, and we will see that along the way. This talk is about rendering. And when I say the word rendering, what I'm really talking about there, let's just be really explicit about it, is I'm talking about creating things that a browser can display. So that might be generating HTML and then returning that from some sort of web server, or it might be manipulating the DOM in the browser, so doing things client side. We used to talk about serving HTML, and maybe we'd talk about DOM scripting, but the language changes over time. And so really what I'm talking about when I'm saying rendering is I'm saying manipulating what the browser will display to the end user. And the when and the where of when that happening is something we'll dig into. I'm conscious of language changing as well, because I think the first time I mentioned the phrase rendering in polite company was at the night before a conference once upon a time, and I was doing a talk about something related to this, in fact. And I was talking to someone, and I said something or other, and I used the phrase rendering on the server. And the person I was talking to just started laughing in my face because they thought that was a ridiculous phrase. They said, "Do you mean serving HTML?" And indeed, I did. That's exactly what I meant, because it used to be simpler, I think, once upon a time. It used to be that we would have dumb pieces of machinery, and I say that with the most possible affection. Web servers used to be things that would return assets that had been generated. They were static. They were something that would just return when they were asked for, and the client, the browser, would be something that would display what they found. And well, that was a very simple, lovely world we lived in. But I've just realized I don't have a timer running. Oh, that's a disaster, isn't it? Okay, hang on a second. Okay, I'm on it now. It was a very much simpler world, much simpler environment. But of course, that also was a bit limiting, and as things got a bit more sophisticated, we started building application servers, web servers that could do a little bit more. So they wouldn't just be purely returning the request of the thing that was asked of them, but they might be generating, manipulating the asset before they sent it back. They might be querying databases, what have you, generating something on demand and returning it to the client to be displayed. And then things moved along a bit further once again, and the browsers started becoming more capable. They started not just to be displaying what was sent to them, but via client-side scripting, things happening in the front end. We started to have computation happening there that would impact what was being displayed. So things have exploded over the years, and this is a little bit of a reflection of that, and then we'll talk about some of the ways this has evolved. But I'm very keen on considering robustness. I think it's really important. It's one of the founding principles of the web. It's what keeps it viable. You might hear people sometimes talking about the rule of least power, kind of based on Occam's razor. And this is something that you will find in the W3C principles about using the least power, the rule of least power, really choosing the language which is the least powerful for the given purpose. And that's something that adds to robustness and means that simplicity is kind of kept in place and complexity can be driven out, which is a very nice thing to think about, but it's an easy thing to disrupt as you start building things with more complexity. So, over time, we've moved on from this environment where we've just got things happening on the server and maybe things happening on the client. Now, we're starting to do things differently. I'm very interested in pushing some of this complexity or some of the moving parts away from the user wherever possible. So moving things out of the request chain. So perhaps doing things at a build step, something that happens before a request is made for an asset, doing things before that even ever happens. And now we're also seeing things happening at different parts of this request flow. So maybe things are happening at build times, maybe things are happening in the server, maybe things are happening in the network that's actually delivering the request. So things that are happening in the edge of the network. We'll get into that in a moment. So at all of these stages, there are lots of places where we can do computation. We can do things that are effectively generating HTML or impacting the DOM or rendering, if you like. And it actually happens all over the place. So, forgive me for quoting myself, but I would say by thunder, there are a lot of ways to approach rendering. There's a lot going on, a lot of options, and this leads to a bunch of confusion, which is kind of why I want to give this talk, because we think very often about the place that rendering happens, and that's really important. It's a really important detail, but actually it's more complicated that, or it's more nuanced, I think, than that, because really there's a time that it happens and a place that it happens. So we really need to understand not just where rendering happens, but when it happens as well. So I'd love really in this talk to be able to cover, the what, the when, the where, the how, the why of rendering. I'll try and do a bunch of those things. I'm not going to talk about how, because that's a different talk, but I really want to give an appreciation of what the options are, how to choose between them, why to choose between them. We're already a few minutes in, but I would kind of just give a bit of the scope of this talk. We'll talk for about 15 minutes or so about examining different rendering options and questioning those, if you like. And then we'll have, I don't know, probably a little less than 15 minutes of how we might apply those techniques and some examples and talk about some of the lessons there. And then whatever time we've got left over, as I say, I'm very, very happy to answer questions or have any discussions you like. So that's the plan. Let's see how we get on. So first of all, let's examine rendering a little bit. Let's see what some of these acronyms mean, because there's a lot of terminology, and as I mentioned earlier, naming is hard. And as I did threaten earlier, this slide is now upon us, because I don't know, we've got this acronym soup of all of these different things to do with rendering and with generating content and displaying content. There's a lot of options, and it can be really overwhelming. So let's dig into some of these phrases. Apologies if you heard these before, but hopefully, even if you have heard these before, there's a couple of aspects of them that I think are sometimes misunderstood. So hopefully this will be helpful nonetheless. So let's start with this one, SSG. Static site generation. Now, this is something that's very close to my heart, because I've worked a lot over the years As I mentioned, I currently work at Netlify, but I used to work as a software engineer, putting numbers on screens for traders to trade off, then working at an agency, building things for clients, and lots of places in between. And I'm really keen on this one because it's an opportunity to drive down complexity. So this is static site generation. Well, the where of this is happening in a build server. So in other words, not part of the serving infrastructure, which is accessible by the end user. It's not part of the request time. And when is it happening? Well, it's happening before, any time before a request has even been made for any view of the service or the site that you're offering. Typically, this is now happening through some level of automation. In fact, I should probably put this little diagram up as well, just to kind of help illustrate where in, this is the view of something I had earlier on the screen, just as a bit of a summary. Where is this happening? It's happening in the build server, and as I mentioned, it's happening before requests come along. And as I say, these days, this is becoming more compelling than it used to be. This was the old school way of doing things, realistically. But now it's becoming more compelling because of continuous integration and continuous deployment. So the opportunity to automate builds, automate deployments, and really streamline this process is what makes static site generation compelling. I like to sometimes put this diagram up as well. That illustrates this, and I'm conscious of some of the language again can be a bit emotive on here, not on this bit, but as we get further along. So perhaps a traditional serving stack, and again this is very simplified just for the sake of illustration, might be client devices are making a request, and those requests need to travel ultimately to web servers or an application service, but they might have to travel through load balancers being farmed out to one of a suite of web servers, which might be getting data from one of a suite of database servers, and all of the routing and abstraction that happens between them. The stack, which again, I'm conscious of the word Netlify on here. Again, it's not a product pitch, but this is a simplified kind of form of that, where static site generators can create assets that you put on a content delivery network, so they're much more available for when the requests come along to get hold of those assets. And static site generators can run in some sort of build that happens earlier on, and those builds can be triggered by things happening in code and content wherever those might live. So this element that happens ahead of time really kind of decouples things from the complexity and the risk for the user, which is great. And as I say, this smells a little bit like a pitch because the way I've worded this, but let's not beat around the bush. Netlify didn't invent this. It's something that enables it these days, but it certainly didn't invent this. These are principles that have been around for a very long time, but the tooling has changed now to enable that. In fact, I think it's probably better to change the word Netlify to various increasingly popular providers. There are a bunch of places that do this stuff, but it's a model I think is really, really powerful, really efficient these days. Okay, we'll come back to some of these pieces. I want to burn through some of these bits of these acronyms, and then we can get on to some examples later on. So CSR, client-side rendering. So many people will be very familiar with this, I'm sure. Where is this happening? Well, this is happening, surprise, surprise, in the client, in the browser, the consumer of this of the views, the thing that presents the views to the user. When is it happening? Well, this is happening after things have been requested and after they've been delivered. So once things have come down the wire to the browser at interaction time, if you like, at user interaction time, rendering is happening right there in the browser using JavaScript. Now, this is incredibly popular. It feels very, very dynamic, and it powers a lot of the web at the moment. JavaScript, however, is less fault tolerant than HTML. Browsers are very, very good at skipping over the wrinkles and the errors that exist in HTML and the code that we as humans create. But they're not so good at being fault tolerant to JavaScript. So it can be a bit more fragile. However, it's incredibly popular and it's incredibly powerful. Harry Roberts, who's a web performance consultant that you may have come across in your studies and in your travels, describes CSR, client-side rendering, as the fastest way to build a slow website. The tooling is really popular for it, but it includes some foot guns that we need to be a bit careful of. However, let's not discount it. I just want to be able to talk about it because manipulating views in the browser using client-side rendering is super, super powerful. Okay, let's keep moving on. CSR. Now, this is where, for me, some confusion comes in with terminology. It feels like there shouldn't be. It feels like it, on face value, it should be very, very straightforward. But there's some nuance here. So SSR, or server-side rendering, where is that happening? Well, it's happening in the server infrastructure. When is it happening? Well, this is happening at request time. So in other words, when a user makes a request for an asset, the generation of that view is happening in some serving infrastructure as a response to that request being generated. So this is happening server side at request time. Strictly speaking, though, what are we talking about when we say server side? Because I hear the words SSR being referred to wherever there's a server involved. And I mentioned the phrase build server earlier on. That's a server. It's not in the client for sure. But is that server-side rendering? Well, it's a bit tricky. If we think about this view again, realistically, what are we talking about? There's the client side and there's the server side, or is that the server side? All of that stuff. It's certainly the not client side. There's client side and there's everything else. What I see is the terms SSR being used to lump all of these things together sometimes, which certainly is accurate in terms of it's not the client, but it can be a bit of a confusion for the when, which is what I mentioned earlier on. The when things happen is really important here. So SSR, strictly speaking, is happening at request time on a server in response to that request happening. Okay, so it's this bit. There are other parts of this chain as well, though. So so let's talk about those for a moment. Here's another one of that request, sorry, that acronym soup that we had earlier on, ESR, so edge side rendering. Again, this is not new terminology. Actually, it's being sometimes talked about as if it's brand spanking new terminology. Realistically, big content delivery network providers that used to be the domain purely of giant enterprises, they've been talking about edge side rendering for a very, very long time. But it's just kind of coming back into the common parlance for mere mortals like myself, people who are engineers, people who perhaps have had more traditionally front-end engineering skills. This is now coming into our remit as well. So we should definitely be talking about it. So edge side rendering, this is not happening on a server per se, but it's happening not on the client. But this is happening in response to requests coming in. So this is happening on the edge. When I say the edge, let's define that just for a moment. This view over here I showed earlier on, this bottom layer, this kind of this different, slightly more modern, more popular stack, or increasingly popular stack or approach to serving as much as possible from a CDN, a content delivery network. In other words, a network of infrastructure globally distributed so that you can get assets geographically closer to the users, so that when the time comes that they make a request, they literally don't have so far to travel, and they can be heavily cached and optimized and all the rest of those things to try and deliver things quickly. When we say the edge of the network and the edge in edge side rendering, we're talking about things, I guess it's not quite in the CDN, but it's at that, almost like that place. So it's at the edge of the CDN, really. It's at the edge of the network, close to the user, so that serverless functions and serverless infrastructures can let you do rendering on demand very, very rapidly in places that are geographically close to the user. So that's edge side rendering. We'll see an example of that shortly. I promise you this won't just be all defining acronyms. We will get to the point that we actually talk about how these applies and look at an illustration. I'm very keen, as I mentioned earlier on, as pushing as much on that bottom layer, as much to the right as possible, getting some distance between the user and the requests that are happening and the complexity. I like things to fail close to me as a developer, not close to the user. So I like to do things upfront as much as possible. I sometimes use the analogy of a kitchen. You don't want your mistakes to leave the kitchen if you're working in a restaurant. You want to see those before they cross the pass. So I like things to be done in a build as much as possible. However, we want to use various different opportunities here. So we'll talk about that. So you might be saying, so you think SSG is best, do you, Phil? And my answer to that would be, it depends. And I would hope that if I say it depends, your response to that would be, well, what does it depend on? It depends. It's a really valuable and important thing to use in a discussion. I think when we're talking about architectures, it sometimes gets dismissed as, well, you're just shirking, you don't want to have an opinion. But it depends is really valuable, as long as it's followed up by, it depends on what, and a discussion about that. So when that happens, I'm glad you ask. When I was talking about this recently, I was kind of curious about some different approaches to rendering. I did what most sensible people did. I took the discussion to where fruitful and beneficial, respectful conversations happen. I took it to Twitter, and this is an archived tweet from that conversation. Let me blow it up a little bit. There was a debate about what server-side meant there, and I kind of echoed what I've just been saying a few moments ago. Server-side doesn't mean server full. In other words, there is a server. I was trying to differentiate between client side and other stuff. And also kind of reflecting on this thought of the rule of least power, my approach tends to be, if I can do things in advance, I will, for some of the reasons I mentioned a moment ago. If I can't do things in advance, but I can do things serverless, I'll do that. And if I can't do things serverless, then but I can add a server, I will. So I'm always prepared to add more complexity if the situation demands it. The thing I prefer not to do is jump straight to the most brute force, heaviest, most complex solution. Even though that's likely to solve my problem, it brings other baggage with me. So I like almost like it's not really progressive enhancement, but it's a similar kind of approach of let's layer things on in terms of complexity when it's supported and when it's demanded. I like to adopt this this rule of least power. It's not absolute, but it's about consideration. Okay, I want to talk about increments for a second. Incremental rendering. This sounds like we're going to go down a rabbit hole, and let's be honest, there's some acronyms in our future. Now, I've got good news for you. The last one isn't a real acronym. That's just my feeling when I see these acronyms, so we can discount that one. That's good news. I've got more good news for you. These three technically kind of mean just about the same thing. And this other one, in some circumstances, means the same thing as well. So we've got a chance to consolidate here. The first three, well, I promise I'll start putting actual words into these sentences soon. The first three they all describe much the same thing, but they come from two different places. I don't know if you're aware, but Netlify acquired Gatsby earlier in the year, and just as a tiny side quest here, our company Slack has recently exploded in conversations about naming things. What should we name the company? Well, spoiler alert, it's still Netlify, but the conversations did have suggestions for Gatlify, Netsby, Getslify, Natsflibby. I'm not making this up. These are all suggestions for naming things brought by the people from Netlify and from Gatsby. It shouldn't surprise you that in Slack, Natsflibby was the, yeah, Ed in chat is confirming this. I'm not making this up. Natsflibby was the runaway winner for the naming. So here's that theme again. Naming is hard. So if that's the kind of debate and difficulty we get in that territory, it's no wonder that these things happen before these companies kind of come together. Anyway, back to the point. Time is ticking on, and we're not getting any smarter as I'm doing that. So let's keep going. So DPR, ODB, DSG. I said those mean largely the same thing. So let's talk about that. So DPR. This is a rendering model. It stands for distributed persistent rendering. Now, this was a convention that Netlify suggested, a model that Netlify suggested a few years ago. There's an RFC that we put out for it, and it describes a way of deferring rendering, if you like, until a particular moment. And I promise I will unpack this. I just want to describe what these things are in relation to each other. So DPR is a model that we suggested. We built an implementation of that, which we called on-demand builders. So on-demand builders were our execution of the distributed persistent rendering model. Oh, acronym soup. It really is a thing. I'll talk about and I'll demonstrate on-demand builders. At the same time, Gatsby produced what they called deferred static generation, which was their implementation of DPR, distributed rendering. So we've got two different technologies, two different approaches doing the same thing. They're finding a way to defer the generation of assets until they're called on. I actually far prefer the naming that Gatsby came up with here, DSG. I really like that, but they're both descriptions and they're both tools that do the same thing. They wait to generate an asset until a request has been made for it, and then they kind of cache it. I mean, it sounds like it's a caching model, but it's a little bit more complicated than that. I think I've described it here. Don't generate it in a build. Wait until the first time it's requested, then generate it and add it to what we built earlier on. So it's almost, I think of it sometimes as the long tail to static site generation. It's something that's not just built in the build when we ask for it, but it's added to those assets that belong in a build when they're requested for this the first time. This doesn't translate very well to an acronym. I tried, but I don't think that's useful. Naming is hard. I've said that before. But the thing is useful is the fact that we've got serverless runtimes now that can live at the edge of networks or different places in the networks and in different environments means that we've got access to producing this kind of logic that lets us do things on demand, execute things on demand in serverless infrastructure so that we don't have to manage a server, maintain that, patch it, all the rest of things, and keep it powered on, cooled, and alive. We can outsource that, and we can simply write functions that live in those serverless environments. And that's the kind of thing that delivers on-demand builders, or whatever you want to call them, that do this kind of long tail aspect of rendering. I did say we'd also talk about ISR. So ISR has a few different forms, but in many forms, it's exactly the same as DPR or ODB or DSG, this long tail of rendering. ISR is incremental static. Yes, Carol, I will talk about that in just a second. So ISR, incremental static regeneration. This is popularized by the Next framework, the Next JavaScript framework. It's actually an implementation of, brace yourselves, another acronym, SWR, stale while revalidate, which is a caching model. So ISR is a form of incrementally generating more things that go into the build, and also of refreshing them. I should illustrate that with a diagram because it sounds like I'm just saying lots of words. So let's do a bit of a comparison. So on-demand builders. So this is the Netlify's model for this long tail of build, if you like. Here we have a render or a build that happens ahead of time. We're combining data and templates into a bunch of assets, and then we're going to put them somewhere that the user can get to them. We're going to put them on a server. But for on-demand builders, we're not going to do that. We're not going to generate a particular view of some things until they're asked for the first time. So a user will come to a URL. There won't be an asset waiting for them, but instead it will hit a serverless function or a code function. And Carol, I promise I'll expand on this in just a second, which will execute. It will generate the response that's needed. And then it will, so that will then exist, and then it will be cached and added to the pool of assets that's already been generated, so that future users, when they come along and ask for that asset, it exists already. It doesn't need to be generated. That's the on-demand builder way of doing it. ISR is a little bit different in that typically a view of many of these assets is generated either during the build or potentially for the first time it was hit. But then when a user comes along, they will get whatever was generated before. They will get a stale version of that. So often it's a placeholder version of the view. And then when they make that request, they'll get that stale version. But the fact that they've made the request will refresh that. I don't know where I am on my builds. Hang on a second. So there we go. They make the request, they get the asset, and that refreshes that view. It revalidates that view, if you like, updating it so that the next person, when they come along, they get a more up-to-date version. And this keeps on happening. So each time a user comes along, they may make a request, they get the older version, but then a new version is put in its place for the next user. It means that the view that's displayed to people is nearly up to date more often. And so this just keeps on going for each new request. Now, I should say that you can configure ISR as well, so that it has a few different behaviors, but this is typically the most common behavior. So you might be asking, which is better, ISR or DPR? And my answer would be, it depends. And I'll come on to that in just a second, but I want to address Carol's question about, can you talk about the differences between server and serverless? Okay, so Carol, tell you what, I'm going to jump around in my slides, because why on earth not? So I had, hang on a second. I could be sending us terribly off piece, but I think we'll be fine. So I had this slide earlier on about different parts of the infrastructure. Again, this is a simplified view, but that's fine. So at the right-hand side, we've got the client, the web browser, and then over on the left we have, or towards the left, we've got a server, the web server. So this is physical infrastructure, physical or virtual infrastructure, but ultimately it is a logical server. It's a server that has an application running. It's a stateful server. It's something that is active and maintained, and you can think of it as typically as a physical machine. And so that's something that's persistent. It lives on. It's a computer. Serverless is rather different. I think a better way of describing serverless actually is functions as a service. That's a slightly more descriptive way, I think, of thinking of serverless. So in other words, this is something that isn't executed client side. It's still something that's executed in the hosting infrastructure, if you like, in the back end, in the server side, but it doesn't exist on. It doesn't include a stateful, always present, always running server. Is actually, in infrastructure that just exists so that your function can run, and then for your intents and purposes, it's gone again. As a developer, as someone maintaining it and deploying in this way, you only think about the code, you don't think about the infrastructure. So you're writing functions that can be executed somewhere in someone else's infrastructure, and you don't need to care about all of the gubbins that goes along behind it. So people often say, I think you'll find there are servers involved in serverless functions. There absolutely are, but they're out of your problem space, they're out of your domain. You never need to think about the actual hosting server and keeping that alive. All you need to care about is the function. So functions as a service, I think, is a nice way to think about it. Let me see if I can find, I know I was at a different slide at one point. Let me see if I can navigate my way back again. Okay, I think we talked about ISR. I said it depends. And on what does it depend? What does making some of these choices depend on? Well, deciding what tools to use demands questions, and that is probably the most important takeaway, I think, from this talk. It's about asking the questions, and the questions really need to come from what are the requirements. So whenever you're trying to choose which of these types of tools to use, it's really important to understand the requirements and start there. So let's talk about some examples of using these things to illustrate this a little bit better. So I'm going to show you a couple of things that I've been involved in building. They're basically, well, one of them is my own site. It's a toy to allow me to explore some of these things, but it allows for a bit of an illustration of these things and some exploration. So the first example I'm going to talk about is a little bit topical. I guess it's still topical. It's still going on, but self-hosting social posts. This is an example I wanted to have. As I mentioned at the start of the talk, been on Twitter for a long time, and I've decided that I would want to take all of my posts and host them on my own site instead of just expecting them to live on Twitter forever. But this is quite a nice example because it gives us a chance to look at some interesting requirements. So let's talk about the requirements. So I wanted a site where I could have a URL for many thousands of things. So in this case, they're tweets. So I wanted a unique URL for 24,000 or so tweets. I also wanted to have index pages that list all of those tweets, so that it would be a crawlable site that would the content that lives on those URLs be discoverable. So I wanted index pages that listed all of those things. I wanted the ability to search the content of those tweets. I wanted to retain a reasonable build time. So my site is a pre-generated site. I use a static site generator to build it and deploy it. And I didn't want the addition of 24,000 new URLs to make that a slow build that's painful and expensive to run. I wanted to keep that reasonable. I wanted to avoid client-side rendering if possible, because again, I like the idea that my content exists as files and assets that are spiderable and discoverable, and also aren't contingent on the environment of the user, the scripting environment of the user. I wanted just to keep that nice and simple. I also wanted, and this is a key one, I wanted a logical model that fits in my head, because once we start stitching these things together, it can get complicated. So I wanted it to be logical. So with those kind of requirements for this little example project, I decided that I could use a static site generator still. I would use some on-demand builders to generate some of these things, and I would use some edge-side rendering as well to do some other aspects. And I'll show you what that was. This is made possible by the fact that this data was abstracted into a format. It was abstracted into JSON. So I had the dump of all of my data that I could then apply to templates to express it. And this is how it kind of looked. This is how it worked. So I have my build, which is my website build, which now starts to call in the JSON of of all of my new content and some templates. It calls that in at build time, and it generates a bunch of assets. It renders the views of all of those things. The things I'm rendering there are all the rest of the content pages of my blog, and also these index pages of all of my social posts that I mentioned. So these are all generated at build time. And then when the user comes along, they get one of those assets, it's ready to go, it exists already, it's on the CDN, so they can view it. And so excuse me showing my blog for a moment, but this is what this looks like. So this is my list of my tweets that exist, or some of these are on Mastodon now, but I've now got pages. You can see I'm paging through the index pages of 955 pages of listings of my tweets. It's embarrassing to look back at what the tweets are from 2017. I'm talking about Rails, interesting, I've moved from that. Mostly I'm talking about what I'm eating. It's riveting stuff. It's important that it lives forever. This has a URL, so you can find it on hawksworks.com/notes, and it's paginated, so each page has a URL. So that aspect has been satisfied. And the build duration is about 2 seconds to generate that content. So it's however many pages I had. You can see my build logs kind of running in the background. It's however many content pages I had. It's 955 new index pages. Locally on my machine, that build runs in about 2 seconds. It's using a static site generator that you see 1.95 seconds. Static site generator called 11T. Running in this CI/CD environment. So this is on Netlify. That includes bootstrapping the environment, running the build, pushing the assets to the CDN, and then kind of shutting things down again. That took about 30 seconds. So anyway, my build duration remained at 2 seconds. Great. I'm satisfying my brief so far. Okay. So, but then I don't have a URL yet for every single one of those 24,000 tweets. So how do we do that? Well, that's where we use an on-demand builder. So this is the distributed persistent rendering, if you like, model, the on-demand builder. What happens here is a user makes a request for any one of those specific tweets. Doesn't exist yet, it's not part of my build, but the on-demand builder, the function, it's just purely a JavaScript function, can then, when I make a request to it, it can go and look at that same blob of JSON, all of the data that I've got there, find the right tweet, apply it to a template, add that to the assets that were created in my build, and it can return that to the user. In future users, if they come and ask for the same tweet, it exists already, so we don't need to process that. Is the ODB a web worker on Netlify? It's not a web worker, no, but it is a serverless function. So think of it as a Lambda function or a serverless function, which has some particular characteristics for how for what it does with the response that it generates. So when I run a build on Netlify, it generates a load of assets that get put into an immutable kind of atomic deploy, a big pot, which is that deployment. Whenever an on-demand builder is executed, it will add another resource to that pot. It does mean that you can roll back to previous builds and roll forward, and things remain kind of immutable, and you can do instant rollbacks and what have you. But no, it's not a web worker. It's just, strictly speaking, it's a Lambda function with some particular caching characteristics. So let's I hope that answers your question. So let's have a look at that. So let's click on one specific link. There we are. It's not exciting. It's not I mean, yeah, this is why this is important. Started my day by making the perfect piece of buttered toast. Okay. I didn't claim that the important thing about this talk would be the content of my tweets, but it's good that this now has a URL that it lives on. So this is an example of hitting a URL. It was making the request to get the data, returning that. It took milliseconds to do, but future requests won't need to do that. It will just return that asset. And there's a URL for that. Great, let's move on because it's crikey, time's getting on. That's okay, we'll get through this. Let's talk about this other aspect, search I mentioned. So here we're going to be using an edge rendering for that. So what happens here is when a user makes a request to search, when they do a search query, we hit another serverless function. This is an edge function, so slightly different characteristics, but it's still a serverless function. That will access the same stash of JSON. It will do a query for that, and it will render a view back to the user. Now, I'm not caching that. I'm not adding that to the deployment. I'm just purely returning that to the user. And this is the search results page. So I'll show you what that looks like as well. So here, if we start typing into this box, when I do a submit of this form, if I search for Palo Alto, there I can see of my 24,000 notes, I've got 3 that match. What am I talking about? 2010, I was talking about where people can find an iPad in Palo Alto for some reason. And I was talking about, what's this? 2008, talking about the prolific oven that has good cakes in Palo Alto. I hope that's still true. I hope that's still there. The important thing here is that these search results exist now on this URL. So you can share this URL. I still don't have a server, but things are happening not client side, but kind of server side, if you like. And so that's using an edge function. So there's a way of stitching a bunch of these different rendering models together. And I'm going to keep rolling quite quickly because I'm conscious of how much time we're actually almost out of time. So I'm going to go very, very fast through this next bit. So I have another example, which is kind of similar. This is for an affordable housing project in California that I've kind of done the architecture for. It's very similar. So I wanted a URL for all the properties that are there. It's very similar, in fact, to the previous example. In index pages, listing all the properties via URLs, an ability to filter and search, very similar. I wanted to retain reasonable build time still, avoid client-side scripting still, and have content maintainable by many people. So, you know, I'm using same features that I was using before, actually, but there's just one slight difference. So this is the model we had before. Here I've got a slightly different aspect in that the data is coming from a different place. You know, the data is abstracted into Airtable, but otherwise everything was exactly the same model as I was using a second ago. I just wanted to kind of show you this as a little example as well. I'm not going to linger on this just because of time. But this is a content managed site that has a bunch of different content pages on it. These are all kind of statically pre-generated. But then this page is a fairly rich search page that allows for searching and filtering of all of these resources that are managed in Airtable. Some of these things are now being rendered, you know, on demand in on-demand builders, but this search is using edge functions to allow us to search and share and bookmark search results. I'm going to move on from this just purely because it looks different, but ultimately there are similar things because I want to talk about lessons. So what did we learn? We're on the home straight, folks, so I won't keep you too much longer. So amid the confusion, what did we learn? Well, hopefully I'm demonstrating there's no one right way to do things. You know, people get very kind of religious about the tools that they use and the model that they use, but really there's no one right way to do things. I like to do work ahead of time if possible, in terms of, you know, when do we generate things? I think it's just safer and more efficient, but we can absolutely mix and match these rendering models. There are lots of ways that we can recombine them. Critically, I think we should never choose an approach until we understand the requirements. If we don't understand the requirements, then we might be choosing an approach that's either not fit for purpose, not powerful enough or too powerful and too complex. I think understanding the requirements is absolutely key. So that's a real key learning, as is that not all of my tweets are pure gold. That's the other thing maybe we've learned along the way. We also learned that naming is hard. I would say that if you're interested in this kind of area and want to learn more and want to look at some more tangible examples and kind of dig deeper, there are a load of them on the Netlify blog. There's a section of tutorials which exposes a load of these things and actually has some more practical how to do it rather than just the what and the why. And so that should be a useful place to go next. I've run 3 minutes over, so apologies for that. Happy to take questions if people either have questions or you can, of course, find me on social media places and ask me there. But there is a question, so I'm just going to. Ashley, am I okay just to keep answering questions until you kick me out?
I'll keep recording until all questions are answered, and then keep the room open as long as people want to stay.
Oh, okay. All right. Okay, super. So this question, those options, ODB and ESR are in the advanced settings for a Netlify build, Lambda paths, any public GitHub lab repos. Yeah. So, well, actually, yes. So my site, the repo for that is public. You can get to all of that. What I will do is, hang on a second. Can I do this elegantly without losing some of my screen sharing? I'll pop a couple of URLs in here. We have there's a great playground for edge functions that has a bunch of examples. Bear with me. I was saying to Ashley before you all joined, the reason I pre-video these demos is I cannot speak and type. I fall over if I try and do it. But let's see if this is true. Yeah, it's definitely true, isn't it? Here we are. So here's a URL which has some examples of edge functions. So you can explore that. You can see some examples there, dig into the repo. These are edge function specific, but there's also a link to the Netlify docs, which has lots of examples of how to start with serverless functions and on-demand builders also. In the Netlify blog, you'll also find a bunch of public repos that we link up to in our tutorials there as well, so you can absolutely explore those. But yeah, a good place to start. A good place to start, I don't know, an honest place to start. I'm honestly showing you my own code, warts and all, is from the repo that runs my own site. This isn't the canonical example for all things. That's certainly true. Let's see here. Oh, so I'm going to get you the repo link. This is better. Here we go. Here's my chat window. Oop. There you are. I'm letting my guard down and warts and all showing you the repo for the site that I've had for many years. But you will find in there the examples of all of the edge functions that I use. And in fact, on my blog, I do also have examples of doing different kind of searching and different examples there that I've tinkered around with, and you're welcome to harvest it for whatever is useful to you. I do also see you're welcome, Amy. I do also see a hand up. So Andre, do you have a question?
Yeah. So I joined a little bit late, so you may have covered this at the very beginning, or maybe not. So what is the software that one uses to make the sites using these mechanisms? When I guess I'm more interested in the serverless solutions, and how this is kind of a continuation of part B of my question from Shay's presentation earlier. It just feels like it's still kind of complex, and you're really rolling up your sleeve. Like eventually, I've been in this field for a long time. Eventually frameworks come and they make things simpler. Are we at that stage yet?
That might be a big question. And it might be a question of taste as well, somewhat. So yeah, I think you're quite right that frameworks come along and they kind of pave the cow paths, and they build abstractions for us, and they give us utilities, and that's great. I'm a big fan of that. What I'm cautious about is when frameworks get so big that they become very opinionated, which is also great as long as their use case and their opinion matches your requirements and your opinions. What can be difficult is using a very powerful, fashionable and popular tool to do something it's not quite intended for, which I think is a trap that we often fall into. That's not to say that I don't think frameworks are valuable. I just think you need to be cautious about how you choose them and what selection you're making. And that kind of comes back to my statement earlier on about assessing the requirements and choosing things according to those requirements. I do think it does look a little bit like, oh, we had this nice kind of cling wrapped, shrink wrapped product that did all of the things that we needed, and now we're breaking it apart and we're rolling all of these things our own, which means we've got to manage them. Yeah, so exactly. I think that definitely can that can be a problem, and it can feel like a problem, but it also isn't always necessarily so. So an experience that I often have is with large enterprises in particular who've spent a lot of money on expensive products that have, they term it as, they often use the expression, they've got one throat to choke, which I don't love as an expression, but one product to blame and one company to have responsible for it. But a large application that can do everything. It's a CMS, it's the web application server, it's the logic, it's everything. It can do e-commerce, it can do everything in one shop, one spot. The problem I see often with that is that they're so big and they're intended to do everything for anybody. Makes it very hard for anyone to use it to do the thing that they need. I've seen that time and time again, because the complexity is actually huge in there, and you have to be an expert in that specific product. I think if you can just use some smaller, I apologize for using the word just, if you can instead use smaller pieces of well-defined, smaller scoped tools, sometimes that can be advantageous. I would never make the claim that the same model is appropriate for every solution, every challenge. I think that's, again, comes down to choosing your tools based on the requirements, but knowing what those are is kind of key. I also think that the tooling has evolved so much more now that it's becoming easier to integrate these things together. I think there's part of the question about what's the software you're using to do these things. So for serverless functions, I mean, we're writing JavaScript functions, right? It doesn't feel like we're using a whole product suite. We're creating discrete functions. We're putting them in a particular place in our repo, and then the infrastructure, be that Netfile or be that wherever else there are conventions for, you pop it here, and then it will be interpreted as a serverless function as a service that will be executed when your users hit it. And agreed, the more complexity you add in, the more you have to understand. But also, I think it exposes that so that you have the ability to understand it rather than it be hidden in magic, which is one of my criticisms of large monolithic application stacks, for example. I spoke for a long time after you asked a fairly succinct question, so I apologize for that.
Well, no, actually, okay, so you were hitting toward the end. So if you were to tell someone the name of some software so that they could start down this path, what are the names that would come up for you? Okay,
I mean, I covered a broad set of things there, but I think so I would look first to, I'm very keen, I keep on saying, about static generators and pre-generating sites, and there's a bunch of interesting tools there for that. So I would look personally at tools like Astro, Eleventy. I would also look at Nuxt, I think is also very good. Next is a large one, but I don't think it's quite so well optimized for static generation. I think it's a larger framework that can be a little bit broader. So I would, if people are interested in build tooling to generate sites based on templates and data, Astro and Eleventy I think are fabulous. Nuxt is good for that as well. So thanks, Joseph. So yeah, so there are tools that exist built on top of kind of the React frameworks or Vue frameworks as well. But those tools I just mentioned are good places to start.
Perfect. Thank you.
Yeah, you bet. Any more questions? I know we're coming up to the hour. You're probably all desperate to nip to the loo before you go to another presentation. Any more for any more? I think you might find that Ed, who may or may not still be in the chat, will be doing a slightly related talk very, very shortly, should you have the appetite for it. He'll probably go a bit deeper into the actual how rather than just the some of the what, but I think there will be some things that are related. Okay, well, if there are no more questions, I might turn it back over to Ashley. But as I say, if you seek me out on the internet, Phil Hawksworth, I'm happy to answer questions that come up later, either via my site. I have a form on my site, or if you can find me on Mastodon. Again, I'm always very, very happy to answer questions. Oh, what's the name of that talk? I think I know. 1 second. I suspect Ed is getting ready for it right now, but
It is building full stack serverless applications, and it is starting in a minute.
Starting in 1 minute.
Mm-hmm.
Great. Well, thanks all. Thanks for your questions as well, and hope that was informative. And yeah, again, thanks for having me.
Thank you very much, Phil.
Thanks then.